Hello, and welcome to the first public open house for the Township of Centre Wellington's Bridge and Transportation Network Study for 4 bridges. My name is Andrew Dawson. I am a professional engineer with RJ Burnside and Associates Limited, also known as Burnside. Burnside is the consulting engineering company that has been selected by Centre Wellington to work with the township and the community on this bridge study. Burnside will be presenting this virtual version of the first public open house material on behalf of the township. Thank you in advance for your time to review this presentation. We appreciate your interest in the project, as consultation with the community is a very important aspect of this study process. The Township of Centre Wellington has initiated a bridge and transportation study to review options available for 4 bridges, bridges 2WG, 3E, 5E, 7E, which are located in a localized area southeast of Fergus. The 4 bridge locations and an outline of the study area are shown in the key map provided on this slide. The 4 bridges are watercourse crossings of the Speed River and its tributaries. 3 of the bridges are located between Side Road 30 and Wellington Road 22 on 3rd line, 4th line, and 6th line. The 4th structure is located on 3rd line, just north of Eramosa-Garifraxa town line. A closer look of each of the structures will be provided in the coming slides. All 4 structures are over 100 years old and have deteriorated significantly to the point of closure or significant load restrictions as a result of concerns identified related to the remaining structural capacity. As part of this study, the township would like to engage with the community to gain an increased understanding on how these bridges serve the local stakeholders such as property owners and businesses within the study areas, users of the road networks related to these bridges, and agencies or organizations with an interest or regulation over the works, such as conservation authorities. The township will collect comments regarding concerns and recommendations from the stakeholders for consideration throughout this study. As part of the study, the role of each structure within the overall transportation network will be evaluated. The study will look at how the closures of bridges have or may impact cross-community travel times, emergency service response, and connectivity to the surrounding communities. A series of investigations of the existing conditions and future development plans will be conducted in order to allow for each site to be assessed in a meaningful way to determine what opportunities may be available to be implemented at each location. These investigations will be elaborated on later in this presentation. In addition to looking at the individual bridge sites, the study will also look at the study area as a whole, recognizing that the proximity of these structures produces a scenario where implementation of a specific strategy at one location may have an effect on what would be the preferred option at another of the nearby sites. The goal at the end of the study is to have an informed decision made on the most suitable alternative for the study area as a whole, and what the preferred means of achieving this overall plan is on an individual site basis. These results will guide the township's capital planning for the future of these bridges. Shown on the screen here is an overview of what the study process will look like. The project has already commenced, and the problem and opportunities of the study were just discussed on the previous slide. We are here today to consult with the public to introduce this study and provide some background context on the study in hopes that those listening will provide their comments as it relates to the problems and opportunities to be addressed through the study. As will be seen later in this presentation, a series of preliminary alternatives have been identified and will be further reviewed following review of comments from the first public open house. The project team will then be completing several background investigations and field studies to gather data and will utilize that data when evaluating the alternatives and selecting the preferred options. Once the preliminary preferred option is selected, an additional open house will be held to share the findings of the evaluation and the preferred alternatives. Comments from the second open house will be reviewed and the preferred alternative will be confirmed or re-evaluated if required. The findings of the study will then be documented in a report, which will be made available to the public for review and comment prior to the study being officially completed. We will now provide a brief overview of each of the bridges in the study. Bridge 2WG is located on 3rd line, approximately 330 meters north of Eramosa-Garifraxa town line. The structure was constructed in 1921 and is now over 100 years old. The bridge is considered narrow, as the driving platform width between barriers does not meet current standards for a typical two-lane bridge. The bridge is a reinforced concrete through-girder bridge. This means that the large barrier-like concrete elements on each side of the bridge are actually the main load-carrying elements of the structure. This type of structure is generally no longer constructed, as it is considered a non-redundant structure, meaning that if one of the two girders failed, for reasons such as significant deterioration or vehicle impact, the entire structure spanning over the watercourse would collapse catastrophically. As can be seen on the photo on the right, the concrete in the structure is deteriorating due to its vintage and years of exposure to the elements. This photo shows a significant amount of concrete has deteriorated, exposing originally embedded reinforcing steel, which is now corroded and not properly engaged by the surrounding concrete. These concerns in the main load-carrying elements of the bridge, along with the consideration that structures of this vintage were not designed for modern weight vehicles, has resulted in the structure having a load limit of 15 tons imposed. Bridge 3E is located on 6th Line, between Side Road 30 and Wellington Road 22. This structure is a concrete bowstring arch, which was originally constructed in 1919. While the concrete bowstring arch truss provides a more elegant and artistic means of providing structural capacity for a bridge crossing, it is also considered to be a non-redundant structure, with the risk of catastrophic failure should one of the trusses fail. The bridge is also considered to be a narrow bridge, capable of only carrying one vehicle wide at a time. The structure exhibits serious structural issues related to the advanced state of deterioration. Several structural elements of the truss have significantly disintegrated concrete, with the original embedded reinforcing steel exposed and corroded. This can be seen in the middle photo. The main deck exhibits signs of advanced deterioration, likely accelerated by the exposed concrete deck being exposed to years of salt-laden water. The structure has been previously rehabbed to extend the service life of the structure, as can be seen in the bottom right photo. However, the continued deterioration has led to full closure to vehicle traffic since 2022, after 130 years in service. Bridge 5E is another reinforced concrete through-girder bridge, which is located on 4th Line between Side Road 30 and Wellington Road 22. Similar to Bridge 2WG, this structure is considered a narrow and non-redundant bridge. Bridge 5E was constructed in 1923 and closed 90 years later, in 2013. The closure was recommended following multiple inspections of the structure that indicated progressing cracks and significant concerns of the structure's capacity to carry vehicle loads, due to severe deterioration of the floor beams and the deck slab. Some of these deficiencies can be seen in the photos in the middle and the right side of the screen. The fourth bridge, Bridge 7E, is yet another reinforced concrete through-girder bridge. This bridge is located on 3rd Line, between Side Road 30 and Wellington Road 22. The bridge was constructed in 1920 and was in service for 101 years prior to it being closed to traffic in 2021. As visible in the photo shown here, the concrete on this structure is severely disintegrated in several locations. The main girders have lost a large portion of their cross-section due to this deterioration and have a significantly decreased capacity. Additionally, there are large areas of concrete loss on the underside of the bridge deck and at the location where the bridge deck is supported on the abutments. For these reasons, the structure was closed to vehicle traffic in 2021. Now that we have a bit of a background on each of the bridges, let's look at the options available. For the purposes of discussion and promoting conversations as part of this open house, this slide presents the preliminary list of alternative solutions to be considered for each of the sites. I will provide some preliminary comments related to considerations for each option. However, each of these alternatives will be investigated in greater detail as the study progresses. The alternatives are as follows. Alternative 1, the do-nothing option, would involve taking no action and leaving the existing structures in their current state, allowing them to continue to deteriorate. This option poses the risk of continued negative impacts to the underlying watercourse, as the rust-laden water seeping through the structures and the falling debris from concrete disintegration continue to be deposited into the watercourse. There is also a risk associated with eventual failure of the structure as a whole, which would have significant environmental impacts. This option would, however, be considered to retain the most cultural and heritage value by not disturbing the existing infrastructure. Alternative 2 is the permanent removal of the structure. This would result in there being no longer a watercourse crossing at the location. This would reduce the previously discussed concerns related to the environment by conducting the removal in a controlled manner with an appropriate environmental mitigation plan. The area would be graded to allow for turnarounds and to renaturalize the watercourse. Alternative 3 is the rehabilitation of the existing structure. Rehabilitation would involve repairing the existing bridges to extend the service life of the structure and to increase the load carrying capacity without changing the overall structure to a significant extent. This option would maintain any cultural or heritage value, but would not allow for improvements to the structure to meet current design and safety standards. Although these options will be considered, preliminary review of some of the structures indicate that they have likely reached a condition where it would not be economically feasible to complete rehabilitation, and it is anticipated that the structures would have to remain significantly load limited even if a large rehabilitation job was undertaken. Unfortunately, with the structure types of all 4 bridges, the ability to widen the existing structures is restricted as well. The final alternative, Alternative 4, is replacement of the structure. This would involve fully removing the existing structure and replacing it with a new bridge in the same location. A replacement option consisting of a 2-lane structure with no load restrictions, designed to meet all current standards, will be considered at each site. Consideration will also be given to the required level of service for each structure, and, if determined appropriate, the option of a low-volume bridge with limited load carrying capacity or limited single-lane width may also be considered. It is important to note that the undertaking of this study does not mean that replacement of any or all of these structures will be the preferred solution. Similarly, it does not mean that the preferred solution for any of all of these structures will be removal. The purpose of the study is to evaluate all potential solutions and select based on a qualitative and quantitative analysis. As previously mentioned, the study will also look at the wholesome approach for the overall study area in recognition that the alternative selected in one location may impact the decisions of how to proceed at another site. As such, the study will include a series of evaluations to gauge what impacts the multiple scenarios of the different number of combinations of closed bridges will affect the overall transportation of the area. To evaluate each of the previously mentioned alternatives, they will be scored qualitatively and quantitatively against a series of criteria related to the technical, natural, social, cultural, and economic environments. The technical environment will consider aspects such as how the transportation network is affected, what capacity the structure can provide in terms of vehicle and farm equipment widths and loads, the ability of the structure to pass watercourse flows and reduce the risk of flooding, and whether current design standards for geometry, sight lines, and roadside safety can be met. The natural environment criteria will be weighed based on how the alternatives will impact natural areas surrounding the bridges. This includes impacts to areas such as bird, fish, and other wildlife habitats, especially in the case where specific species at risk are identified, and other environmentally sensitive areas such as wetlands. The areas of impact will be evaluated based on anticipated construction activities and limits of disturbance of each alternative. The extent of impacts and the ability to mitigate such impacts or provide enhancements to the natural environment will help determine the rating of each alternative. The social and cultural environment includes consideration of how each alternative will impact the people and the history of the study area. This includes how the local community, users of the roadways and bridges, farming, businesses, and other organizations within the study area are affected. It also includes the review of archaeological potential in the area and consideration of what role the structures play on providing context to the built or cultural heritage of the area or community interest. Additionally, the economic environment must also be considered. the evaluation of upfront capital and long-term maintenance costs of each option will be completed to help determine the cost-benefit ratio of each solution. In order to properly evaluate the previously noted criteria, several studies have or will have to be conducted to allow for an educated decision to be made. Since the study has commenced, a Stage 1 archaeological assessment and a cultural heritage evaluation have been completed. The Stage 1 archaeological assessment is essentially a background study and visual review of the site to determine the level of potential that archaeological items of interest may exist in the areas that are to be disturbed as part of the works. The study determined that all areas within the local vicinity of the bridge are considered to have low archaeological potential, given that the areas have all been previously disturbed during the construction of the original bridges. Given these findings, no further archaeological assessments are required at this time. The cultural heritage evaluation reviews each site against a set of criteria to determine if the bridges would be candidates for having cultural heritage value or interest. The study looks for structures that are rare or unique in design, craftsmanship, or technical achievement, or are associated with historic value of persons, events, or the overall character of the community. Only Bridge 3E was found to have cultural heritage value or interest. Bridge 3E is a unique bowstring arch type bridge. This type of bridge was historically more prevalent in the Wellington County area. However, at current, there are few remaining. The rainbow arch design was developed by local architect Charles Madiana, who is a historically relevant designer and builder within Wellington County and the surrounding areas, having designed and built many local bridges. As such, Bridge 3E is considered to have cultural heritage value or interest, and a further heritage impact assessment will be undertaken to review the impacts of the heritage features of the bridge associated with each alternative. In addition to those studies already complete, the investigation shown here will be undertaken over the coming months as the study progresses. As just mentioned, a heritage impact assessment will be completed to determine strategies for documenting, conserving, or providing sympathetic design elements of the heritage attributes of Bridge 3E. A team will also visit each site to complete an assessment of the terrestrial and aquatic ecology, completing tasks such as inventorying trees, review of fish species and wildlife presence, and identification of potential habitats and species of interest or species at risk. Public consultation will continue throughout the project and involves 2 public open houses, including this one. Publication of the study-related material online at Centre Wellington's Connect CW webpage, and ongoing discussions with stakeholders through direct contact where requested. The structures will be further assessed for condition and feasibility of design options for rehabilitation and replacements. A review of the existing structures and proposed replacement alternatives' capacity to convey watercourse flows during rainfall will also be conducted as part of a hydraulic analysis. And last but not least, a transportation connectivity study will be undertaken to assess the impacts on cross-community connectivity and emergency response times associated with the current or permanent closures of structures. Now that we have provided you with the background information and findings of studies to date, you may be wondering about the timelines and next steps of the study. First and foremost, public consultation is a very important aspect of this study. As part of this first public open house, we would like to hear from the community to aid our team in defining the problems and opportunities that the local stakeholders would like to see addressed as part of this study. So I ask that at the end of this presentation, you provide the project team with your comments related to what impacts the bridge opening or permanent closure would have on your life, property, business, etc., and to let us know of any specific interests, preferences, or recommendations you have for the team to consider when evaluating each option, or any other comments you feel should be considered. In the coming months of the summer, the team will continue to complete field studies and gather information to complete the previously discussed evaluation of alternatives. It is anticipated that all relevant data will be collected and the alternatives evaluated by early fall. Once the preliminary preferred alternative has been selected, open house number 2 will be held in the fall to share the results of the evaluation and the preliminary preferred alternative with the public. The team will then consider comments, reevaluate or confirm the preferred alternative, and work to have a study documentation report prepared towards the end of 2024. A review period will be provided for the public, which is anticipated to extend into early 2025, at which point the study will be considered complete. So in closing, we encourage you to provide any comments related to these structures that you would like the project team to consider during the evaluation of options of these bridges. There are a few options available for you to provide comments. Firstly, the Townships Connect CW webpage for this project, which can be found at the link in the bottom of this slide, has a questions portal where comments or questions can be submitted. This Connect CW page will also be kept up to date throughout the project study with information as it becomes available. You may also contact the Township's representative, Adam Dickinson, or myself from Burnside by phone, email, or mail using the information provided on this slide. We look forward to receiving your comments and working with the community to determine the preferred solution for the future of these bridges. Once again, thank you for your time to review this presentation and provide your comments to the project team.